must be very good in terms of a hypothesis theory or a hypothesis testing or significance testing. I must be very good, number one, with confidence intervals for small samples where you use T, and the confidence intervals for large samples. Then number two, I must be able to perform a significance test of a single mean. Single mean. Number two, single mean or single, yeah, let's talk of single mean. Number three, mean, I must be very good in looking at hypothesis tests of a difference between two means. And then number four, for the sake of your exams, I would really time the famous chi-square. Already I've done this, but I will be able to repeat today. But I would really want us to right away look at these other areas here. And I would want us to start with August 2023, question number 7B. August 2023, question number 7B. August 2023, question number 7, boy. August 2023, question number 7, boy. The moment you get that question, I would recommend or request to have you guys snapping it. You take a snapshot and then you send it to our WhatsApp groups. Yeah, I will really be very, very happy. You take a snapshot, send it there. It reads, consider the following hypothesis. So U equals 400 for the null hypothesis. And then we have an alternative hypothesis, U is not equal to 400. So is there somebody who has been able to get it? Kindly mention there, Y for yes for me to continue. Mention Y for yes for me to continue. Mention Y for yes for me to continue. August 2023, question number 7. Thanks, Faria. So I'm waiting for another ninja. You know, RCM students, we call them ninjas. Why do I call them ninjas? Because they are really brave. Yeah, they're brave, and they pass their exams. Yeah, already these other ninjas have gotten it. Let me ask the last question before I do it. The two students who have gotten it, have you taken a snapshot of that question and sent it directly to our WhatsApp? Thanks, Brian. Brian always attends all my classes. Brian must be a very good student. So have you taken a snapshot and sent it to our group? Do this as ninjas pretty fast, so I don't inconvenience any student. Would want students in this case here to be good at this. So I'm assuming they'll be able to do that. We are told here that consider the following hypotheses. We have the null hypothesis, what they're denoting as H0, where under H0, they have in this case here, U is 400, sorry. So meaning that, null means empty. Null means empty, meaning that the null, in this case, is that there is no difference. No difference. So the sample mean will be equal to the population mean. No difference. Yeah. And then we have in this case here our alternative. So we have our alternative hypothesis. H1, we have U is not equal to 400. It's not equal to 400. So meaning that the sample mean could either be smaller or bigger. Yeah, so if it is smaller or bigger, it means that now there is a difference. There is a difference. So ladies and gentlemen, let me ask you a question. When you see them here saying not equal, will this be a one-tail test or a two-tail test? Will they use not equal? One-tail test or two-tail tests? Thank you so much, Faria. This automatically there are two tails. Why? Because either smaller or bigger than 400, then automatically in this case here, there will be a difference. So smaller means the tail to the left. Bigger means the tail to the right. So these are two tails. Yes. Now, ladies and gentlemen, after that, how big is my sample in this question? How big is my sample? If you look at the question, they only have 12 observations. So 12 observations. If n is 12 in this question, this will be less than 30, meaning that we are dealing with a small sample. We are dealing with a small sample. We are dealing with a small sample. Whenever n is less than 30, we are dealing with a small sample. And all small samples, in terms of analyzing them, we shall always use the t statistic. We shall always use the t statistic, always. If it's small sample, always use the t statistic. Always use the t statistic. Always use the t statistic like that. Always use the t statistic. Are we together, my good students, up to here? Are we together up to here, ladies and gentlemen? Are we together up to here, ladies and gentlemen? Yeah, and please, I hope you're calling your friends. We agreed. Brian seems to be a good gentleman. We agreed. If you guys will not be more than 50, then it means that you don't need my services. Already you are more than happy. Yeah, you are just waiting for an exam. So I hope somebody is calling people, telling people in this case here, join, because you must be more than, actually, let me pull up the number a little bit, more than 60. SMS them, tell them the class is going on. That is how we normally assess the desire for these kind of revisions. And then now we can talk about bringing the 5 p.m. classes. You can't bring 5 p.m. classes for 20, 30 students. No. That time, I can sell that time elsewhere. And I'm telling you that respectively. So please ensure that we are about 60. 60 is very good. Yeah. So Brian, in this case, you're going to bring these people here. So if you're using the t statistics, then the next thing after you have been able to set this is to come and give us the t tables value. Give us the t tables value. What we call the test statistic. The test statistic or statistics. Yeah, you just told me that, Mwalimu, this is a two-tailed test. So you'll be able to draw it like this, like these two tails. You shade like this. After you shade like this, so now you need the level of significance. For us to read this, we need the level of significance. So is there somebody who is able to see this level of significance in this question? In this question, yeah, you can see the significance level is 0.1. Is there somebody who is able to see the level of significance given under the required? Given under the required, yeah, it is 0.1. So the level of significance is 0.1. Therefore, the level of significance per tail, because there are two tails, it will be 0.1 divided by 2. There are two tails, 0.1 divided by 2. So 0.1 divided by 2 gives me what, you good students of mine? 0.1 divided by 2 will give me what figure? 0.1 divided by 2 will give me what figure? 0.05. 0.05. Thank you so much. So this is one of those data requirements. This is one of those data requirements. The second data requirement that I will need is what we call the degrees of freedom. Degrees of freedom is what we call the degrees of freedom. Is there somebody who is able to remind us of the formula for getting degrees of freedom? How do we get degrees of freedom? Somebody give me the formula. How do we get degrees of freedom? Thank you so much, Chariot. Thank you so much, Faria. So you're taking, in this case here, n minus 1. N is the sample size, which is 12 minus 1, meaning that the degrees of freedom, they are 11. So once you get these degrees of freedom, please go to the back of your past papers. There is a table there called T distribution. A table there called T distribution. T distribution. T distribution. So this T distribution, you are able to see, like now mine here, they have only shaded one side. They have only shaded one tail. One tail. So meaning that they need you to use the alpha per tail. They want you to use the alpha per tail. And the alpha, so they need you to use the alpha per tail, because you see if it were two tails, then they would have shaded the two tails. So they want me to use the alpha per tail. So then in this case here, I will read T, yeah, alpha per tail, because it's one tail, with how many degrees of freedom? 11 degrees of freedom. With 11 degrees of freedom. With 11 degrees of freedom. Yeah, so we are reading T per tail, one tail. So T per tail with 11 degrees of freedom. So basically T per tail, that is T 0.05 with 11 degrees of freedom, with 11 degrees of freedom. So please go up there. You'll be able to see where they're giving us T, like the second column in my case, T.05. T.05. Then you walk this down together with degrees of freedom, 11. You'll be able to see something there. Is there somebody who is able to see something there? 1.796. At least I have one ninja here that is able to read these 1.796. Only one ninja. Only one ninja. How about the other ninjas? So remember, we have degrees of freedom on this column. So these degrees of freedom, I'm going down up to 11. And I'm reading this together with the column written T point. You know, it's written like this. It's written T.05. But you see there is a 0 point. So there's a 0.05. So there is a 0.05. So you walk down with that. So you walk down with that until you see 11 that you are right. It is 1.796. So meaning my good students, what does this mean to me? This is really very, very important. So because these are two tails, the figure here, the critical figure here will be 1.796 positive. Of course, at the middle we have a 0. At the middle always you have a 0. So the other one will be minus 1.796. That is why in the confidence intervals, we normally call it plus or minus t. Plus or minus t. So we have a positive t figure and a negative t figure. A positive t figure and a negative t figure. And then now remember the shaded region, or rather the unshaded region. Unshaded region is the area of emptiness. Area of emptiness. Area of emptiness. I'll be able to answer that. Area of emptiness. So the area of emptiness, we normally call that one the null hypothesis. Anything shaded is H1. This one here is H what here? This one is H1 as well. Significance levels, we give them H1. Significance levels, we give them H1. H1. So please remember, I have not used like one tail. Please, I have not used one tail. You know, to spread the 5% to give us how many tails? 2 tails. So I know that the area here is 0. The area after now, the area for this one tail is 0.05. This one here is 0.05. So 0.005, to give me the level of significance of 0.1. Why? When it comes now to reading, you see reading, the examiner has given you a table that has got only the tail to the right. He has given you, if you look at the table given here for the T, it is the area to the right which is shaded. So they are simply asking you, this area to the right, what is its percentage? It's 5%. So it doesn't mean that I've used one tail. They're guiding you. They're telling you that, for you to be able to read the T values here, just give us the percentage on the right tail, which is only one tail here, but just for reading. And this one tail is the one after you subdivided, you got in this case here 0.05. I hope that is a little bit helpful, because you can't read 2 tails from the table. Yeah, you can't read 2 tails from the table. Now, having gotten that, my good students, then what do? Now we go to the last section. So the last section now is where we do the T calculated. The T calculated. So we'll be able to come here and give our examiner what we call the T calculated. T calculated. How do we get this T calculated? So to get this T calculated is really a simple thing. So you would be forced, first of all, to understand what kind of a hypothesis am I carrying out. This is a hypothesis of a population mean. They're saying that the U, which is the population mean, is 400. And then they have gone ahead in this case here to sample out. Yeah, so they have in this case here a sample mean. So if in this case here it's a single, or rather it's a population mean being compared to being compared to a sample mean, what I will do, I will come and say t calculated is the sample mean minus the population mean all over the standard error, all over the standard error, all over the standard error. So anytime I've gotten the t tables, now we go to the t calculated. To get the t calculated, you look at your two means. If you look at this question very well, my good students, you'll be able to see what I'm talking about. If you look at this question very well, my good students, you'll be able to see what I'm talking about. What am I talking about, my good sons and daughters? What I'm talking about there, look at this question. They are saying for, U means population. The population mean is 400. And then they are telling us, for a random sample of 12 observations, the sample mean was 407. So I would want to see how different is the sample from my mean, population mean. So basically you take the sample mean, X stands for sample, bar means mean. So X bar minus mu all over the standard error. And then you remember very well how to get the standard error. To get the standard error, we normally take the standard deviation over the square root of the sample size. Yeah, we normally take the standard deviation all over the square root of the sample size. Anytime they want you to get the standard error, you take the standard deviation over the square root of the sample size. Have they given me, ladies and gentlemen, the standard deviation of this sample? Oh, yes, they have told me for a random sample of 12 observations, the sample mean was 407 and the standard deviation was 6. So you can see the standard deviation here is 6. So 6 divided by the root of the sample size, you guys gave me a figure of 12. So could you be kind enough and give me this figure? Be kind enough and give me this figure, 6 divided by root of 12. So 6 divided by root of 12. 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 Yeah, they're giving me a figure of 1.732. Thank you so much. Thank you so much. They now come and fix everything here. So meaning that my t calculated will be the sample mean of 407 minus the population mean given, this U. The population mean given is 400. Whatever we'll be able to get there, come and divide this by the standard error of 1.732. Divide this by the standard error of 1.732. Divided by the standard error of 1.732. 1.732. So please tell me, what figure are we getting, ladies and gentlemen, here? What figure are they getting, ladies and gentlemen, there? Is there somebody who is able to get some figure there? How I wish everybody was that active. How I wish everybody was that active. How I wish everybody was that active, because I can see like 3 students have already given me an answer, but there are some ninjas who haven't yet given me any answer. I can see there are some ninjas who haven't yet given me any answer. There are some ninjas who have not given me any answer. So we are getting t calculated of 4.04. T calculated of 4.04. Remember, my answers shall always be in terms of 3 decimal places. The more the decimal places, the better. So 4.041 or 4.042, something around there. 4.041, around there, isn't it? So if you got 4.042, no worries, no worries. So then once you get this t calculated, please go ahead and map this figure on your diagram here. Where does it fit? Is it within the shaded area of emptiness, area of nothingness, or is it in the area of significance? Is it in the shaded area or unshaded area? This 4 point. Remember, this is your number line. So you have 0 at the middle. Yeah, 4 point will be somewhere here. 4 point will be somewhere here. Given the t statistic, given the t tables, 4.041 will be somewhere there. So then we are saying that this is in the shaded area. So then if it is in the shaded area, what conclusions do we make? What conclusions do we make? If it's in the shaded area, it is in the H1 area. Yeah, remember we shall always make decisions on the basis of H0. So basically, if it is in the shaded area, we are saying that we reject H0. It's either we accept H0 or we reject it. Because the figure is in the shaded area of H1, so we're going to say reject H0. That's how we write it professionally. You can't say accept H1. All our decisions shall be based on H0. So you say reject H0, very good. Or reject the null hypothesis, yes. Reject the null hypothesis. Reject the null hypothesis. Reject the null hypothesis. Reject the null hypothesis, because they wanted you, if you look at this question, if you look at this question, using a significance level of 0.1, advise whether the null hypothesis should be accepted or rejected. You can actually even leave it at that stage. That in this case, ladies and gentlemen, yeah, we are rejecting the null hypothesis. You double underline. Simply because our T calculated falls on the shaded area, or falls in the shaded area. Falls in the shaded area. So then what are we concluding at the end of the day? Don't write this. What you're saying in this case, if we are accepting this H1, is that really the sample is quite different from the population. That this sample may have been drawn from a different population, not from this population. We have what we call, ladies and gentlemen, a population. We have what we call a population. Like, for example, we have a sample, or rather, we have a simple population mean. That for every 8 Kenyans you get, 1 is positive. Yeah, for every 8 Kenyans you get, in this case here, we have what here? That is the mean. So what if, for example, assuming this is a class of very, very good people? Yeah. So assuming in this case here that you take, like, say, 30 students, you do an HIV test on them, and then you get, like, there is nobody who is positive. All of them are negative. Then we shall be able to conclude that, these people have not been taken from the normal. We expect what we call normality. So out of 32, maybe I should have gotten like 4 of them being positive, but there is nobody who is positive. So we are saying here that there is a statistically significantly different means between the population and the mean. At your level, you're not supposed to even go to those interpretations. At your level is to say, reject the null hypothesis, accept the null hypothesis. So that is it. I hope you guys have been able to take home something that will be able to enable you get all the marks if you got this kind of a question in an exam. So I would want you later on, you try to review whatever you've done, and try to see whether you can now do it without having a solution in front of you. Is that something that you guys can promise Mwalimu that you shall be able to do later? Is that something you can promise Mwalimu to do later, that later on you'll be able to get the same question and have a look at it? Thank you so much. So then we go to April 2023, question number 3B. April 2023, question number 2, boy. April 2023, question number 2, boy. Wambua, I would really expect you go and repeat. You redo the same question. Now we are going towards an exam and Mwalimu has got his own projections. Do the same question, just that question alone, and you'll be good. Although even the one that I'm doing is quite similar to that. But what I expect is you to go and repeat. You know how we were being told in high school? Whatever you do in class, get time, put the solution aside, repeat. You will really be very good at these things. Repeat. Thank you so much. So we go straight away to this question. I don't know whether they have been able to get it. April 2023, question number 3B. Take a snapshot, send it in the group. Take a snapshot, send it in the group. User is a very good student, and I believe he has been able to send it in the group. April 2023, Question number 2, boy. So I will do 14 questions in total in preparation for your exam, and I believe they'll be able to really help you. Different topics, 14. Oh, they haven't yet sent the question in the group. They haven't yet sent the question in the group. They haven't yet sent the question in the group. So like now here, I'm going to do this one. Next one we meet, I do chi-square. I do difference between two sample means. Now you're given two samples, x1 and x2. Two sample means. You'll be very, very good at that. Once you really get the question paper, you're able to mention why for yes. Why for yes? Are you able to mention there why for yes? Thanks, Jacinta. And have you sent the question in the group? You simply take a snapshot and then you send it there. I'll be so happy and indebted to. Thank you so much. They've already done that. So we are told here the monthly rent paid by residents of a Hillview estate is found to be normally distributed with a mean of 22,150 and a standard deviation of 8,900. On the basis of a sample of 200 students. So you can see the sample there is 200. That is so huge. So the first thing that I'm able to see here is that N is 200, which is more than 30. So meaning that I'm using a large sample for my test. And if it's a large sample, I shall use what we call the Z statistic. So remember, they've told us expressly that this is a normal distribution. A normal distribution ni ile hesabu ya ugali ya Mluya. You know, it's only a Luya who can cook very symmetrical ugali. It's only a Mluya who can cook very, very symmetrical ugali. No other tribe has that blessing. No other tribe has that blessing. Even this one of mine is not symmetrical. So remember, if it's symmetrical, we expect these things. Number one, we expect that if you cut this ugali into two, put a knife in between, then this person will get exactly 0.5, 0.5. Yeah. And then, of course, in this case here, the ugali is able to cover the plate 100%, meaning that the total probability for a normally distributed, function, total area is 1. And if you cut this total area into two because of symmetry, then you shall be able to get 0.5 and a 0.5. Oh, it's like it's not coming up with April 2023, I don't know. 2B. Yeah, 2B, yeah. Great. And then now remember, so it's symmetrical about the mean. This ugali of Mluya is also suspended somehow. Yeah, it will never touch the plate 100%. Yeah. It is normally what we call asymptotic to the x-axis. It comes very close to the x-axis, but it shall never touch it. I've seen these people asking for properties of a normal distribution. Total area is 1. It's called a probability density function. It is symmetrical about the mean, meaning that if you cut it at the mean, then automatically the area will be 0.5, symmetry. And then it is asymptotic to the x-axis. Asymptotic to the x-axis, meaning that it shall never touch the x-axis. And then again, remember another property, just in case they ask, can they give you 4 marks? The property is that it is infinite. It is infinite. It runs from negative infinity to positive infinity. So this is negative infinity to positive infinity. Have you been able to pick those points, ladies and gentlemen, somehow? Yeah, somehow. Yeah. So long as you know like 2 of them, then you are good to go. You are good to go. Now, ladies and gentlemen, if it is a z-score, very easy, really. So if it's a z-score, what have they told us there? They want us to construct a 95% confidence interval for this monthly rent paid. I love confidence intervals. They are easy. 95% confidence interval. will be equal to the mean estimate plus or minus Z times the standard error, like that. Yeah. And then you tell me, are we going to deal with the two tails here or one tail? Are we going to deal with the two tails or one tail? All confidence intervals have got how many tails? Two tails. All confidence intervals, they have two tails. So we have this tail, yeah, and then we have this other tail, like that. Great. Two tails. There are two tails there. Beautiful. So then for us to be able to read these tails, what have they told us there about level of significance? What they have told us, ladies and gentlemen, here is that to construct a 95% confidence interval for the monthly rent. So remember, to be able to get level of significance, we know that confidence interval plus level of significance should be equal to 1. Confidence interval plus level of significance should be equal to 1. Confidence interval plus level of significance should be equal to 1. Please write this in full. Confidence interval plus level of significance shall always be equal to 1. So if the confidence interval is 95%, then I will easily get you the level of significance, because 0.95 plus level of significance will be 1. Meaning, ladies and gentlemen, that the level of significance will be 1 minus 0.95. Will be 1 minus 0.95. So is there somebody who is able to give me this level of significance? Yeah, so this will be 0.05. Then go ahead and give me the level of significance per tail. If it was only one tail, then I would have used that 0.05. But here there are two tails. So it will be 0.05 divided by 2. Yeah, thanks, Austin. So it is 0.025. 0.0. Jacinta, you must have pressed something which is not very desirable there. 0.025. 0.025. So level of significance per tail is 0.025. I don't know whether we are together really, all of us up to here. I don't know whether we are together really, all of us up to here. Thank you so much. Thank you so much. So then we have this is 0.025 and this is 0.025. So then I want to read the Z table's value. Z table's value, when I go to my tables, please go to your Z table. You know, normal tables, we shall always read them using the Z normally distributed function that is given at your past papers. In your past paper, you'll be able to see what is written as a normal curve, or the standard normal distribution. Standard normal distribution. So is there somebody who is able to see that standard normal distribution? Or normal curve at the back of your past papers? At the back of your past papers? At the back of your past papers, anybody who is able to see the normal curve? Anybody who is able to see the normal curve at the back of your past papers? Anybody who is able to see the normal curve? I should start giving presents. And if you have that normal curve, please pick it. If it's a PDF, send it to our WhatsApp group. Thank you, John Morticia. I don't know whether this is in response to whether you've gotten that normal table. Have you gotten the normal table? Faria, you are a very, very good student. Thank you so much. Thank you so much. And if possible, Faria, please try to send that table to the class group, WhatsApp group. So remember, we are giving you this session from RCM Online College, the best college in East Africa. Yeah, if you look at the populations, we have huge populations. So people have a trust in us. So like you guys, whether you like it or not, you can only pass. That one I'll guarantee you. Some of you are coming from different colleges, and of course you'll agree with me. The way like now I'm doing this session is at a different level, great level, high level. Yeah, you're being taught by a civil engineer who became an accountant by mistake. Or I'll be able to tell you how I became an accountant and why I'm calling it mistake. I will be able to tell you that story later after our exams, after our exams, after our exams, after our exams. So, ladies and gentlemen, Brian has been able to send something there. Yeah, thank you so much, Brian. Please pick it. Please pick it. And you have to be very, very careful. You must be very, very careful. You must be able to know what your examiner has given you for you to be able to read this Z table's value. You must be very, very careful. I don't know whether I've got all the tables here with me. So for example, the table that I have, the examiner has shaded everything from the beginning to the upper limit. The table that I have, the examiner has shaded everything from here to here. So then for me to be able to read this, I will come and redraw this in the Z table's value. I will come and redraw it. So this examiner has shaded everything. Yeah, I shaded everything from here, the very beginning, everything, up to the upper limit. Up to the upper limit. So, ladies and gentlemen, this one that has been shaded up to here, we know that it is 0.5, isn't it? It is 0.5. You know, you shaded up to here, sorry, up to the upper limit, this upper limit. But we know that from here, the middle, from this middle to here, it's 50%. Yeah, it is 50%. Let this not confuse you. Let this not confuse you. Yeah, it is 50%. 50%. So now the question is, I need to come and ask myself, my good students, what is the size of this area? If this area is 0.025, if this area is 0.025, what do you think is the size of this one? Aha. (0.45). Remember, up to here is 50%. Up to here is 50%. This other one is 50%. But we know the one section. We know one section. So the shaded section here will be equal to what? The shaded section will be equal to what? Yeah, it will be 0.475 like that. Therefore, total shaded area will be 0.5 plus this. 0.5 plus 0.475, which will give me 0.975. Allow me to repeat this. I don't think I've taught this very well. Allow me to repeat this. I will actually rub everything. Not very good illustration. Let me put it much better. Now, please listen, ladies and gentlemen. You see, the examiner has shaded everything to the upper region. Everything to the upper region, You know, we have Z1 and Z2. Z1 and this is Z2. So this is Z1 and this is Z2. So the examiner has shaded everything up to here. But fortunately, we happen to be knowing this area coming after Z2. We know this unshaded area, I can call it unshaded now, from the table given, is 0.025. So then can you kindly give me the total shaded area up to upper limit, I know what I will do to be able to get this. I know that the area under the entire thing is 1. So 1 minus what is not shaded. So 1 minus what is not shaded will be 0.025 like that. So can somebody then give me this total shaded area from here to the upper limit, from there to the upper limit? What are we getting in this case? Here's the total shaded area. So total shaded area will be 0.975, I'm told. 0.975, I'm told. 0.975, I'm told. Now, please, ladies and gentlemen, I would want to make this thing very simple. when you go, and you know you don't know the table that will be given by the examiner. The examiner will always keep on interchanging these tables. He'll tell you one of them is shaded here. He'll always keep on interchanging, and I have to be at a position of knowing how to read whichever table that is provided to me. Now, the one that has been provided to me is here. So now remember, we have the total shaded area. So inside the table is where we have the areas. So they want me to use reverse gear to be able to read the Z. So please, inside here, look for, inside the table now, inside the table here, look for 0.975. Inside the table. Remember, when you're getting a confidence interval, you read from inside the table to get the Z. So 0.975, if I look at this way, I can see 0.99. I don't want that. I'll go back a little bit. I cannot see 0.97. I can see 0.9495. Now I'm almost there. I can see 0.95. Yeah. 9515. No, I'll go back a little bit. No. I have to get it. I have to get this one. Yeah. I can see it here. 97441, 0.975. Oh, yay. So where I'm seeing this 0.97, actually it's exact. Where I'm seeing this 0.975, by the side here, I'm seeing a column of Z. So this column of Z, I can see it is 1.9. This column of Z is 1.9. But you know I want the second digit. The second digit will be given here. So this, on the top here, we have 0.06. So therefore, the Z that corresponds to this 0.975 will be this 1.9 plus this. 1.9 plus this. So the Z which corresponds to this, so the Z table value will be 1.96. The Z table value will be 1.96. So the Z tables will be 1.96. Allow me to repeat this. 1.96. So ladies and gentlemen, as I repeat this, and I want to give even a present today, could you kindly first of all tell me whether on the Z table, have you been able to see 0.975? Is there somebody who has been able to see 0.975? How I wish you would get a table that is shaded like this. We need to learn how to do this table, and then in my next class, I'll be able to show you how to read from the other table. Yeah, Cheriot, at least Cheriot has gotten it. Hillary Osukenya has also gotten it. Yeah, also Carl has gotten it. Lucy has gotten it. So please, you read 0.975 like I can see it is somewhere here. So then, first of all, I will start with the first two digits under the column of Z. So that is 1.9. But you see, this Z, they always come in two decimal places. So I need the second decimal place. How do I get the second decimal place? I will read the upper values. So then the Z which corresponds to this will be 1 point, either we say 1.9 plus 0.06, or we simply say 1.96. So it's 1.96, 1.96. All right. Now, once I've been able to get that, ladies and gentlemen, I've cleared everything. Before I show you how to use the other table, my good students, please listen. These guys have given me a sample. And the sample they have given me, they are telling me to, they have given me a sample. I can read again. They've told me the monthly rent paid by residents of Hillview Estate is found to be normally distributed with a mean of 22,150 and a standard deviation of 8,900. So already the mean is my estimate. So the estimate here is 22, the mean, 150. Plus or minus the Z that we've been able to read, 1.96 times the standard error. How do we get the standard error? To get the standard error, we normally take the standard deviation. The standard deviation, which is 8,900, we divide this by the root of n. The root of n, the sample size, they're telling us there is 200. The sample size, they're telling us there it is 200. So could you kindly do me a favor? Please go ahead and give me this answer separately. So it will be 22,150 plus or minus 1.96 times, so take this divided by root of 200. So take this divided by root of 200. Divided by 200, give me your answer in 3 decimal places. Let me get standard error by the side. Let me get standard error by the side. Yeah, so they're giving me 62, 9. I suppose chariot is 333. 8900 divided by square root of 325, 325. I think 325, 325. Yeah, thank you so much. 3 decimal places. It's only Z that we allow 2 decimal, others 3. So then because it's a confidence interval, come here and they give me the lower limit. So how do we get the lower limit? We subtract. So it will be 22,150 minus 1.96 times 629.325, which will end up giving us a what figure? Lower limit will be 22,150 minus 1.96 times 629.325. Give me the lower limit. So the lower limit, somebody called Kavrin is giving me a figure of 2916. 2916. Can someone else confirm this figure? Can someone else confirm this figure? Hillary Osukenya has confirmed the figure. Hillary Osukenya has confirmed the figure. Then go ahead and give me the upper limit. Go ahead and give me the upper limit. Go ahead and give me the upper limit. So the upper limit will be when now you add. So the upper limit will be 22,150 plus 1.96 times 629.325. So is there somebody who is able to give me this upper limit? When you add Carl and Chariot, they're giving me 23. Something 23, isn't it? 23, 383.477. So in that case here, then we are 95% confident that the salaries, will fall between this amount and this amount. We are 95%. You don't have to write that. The moment you've done the lower limit and the upper limit at your level, nobody would even want interpretations. So if you remember very well, sometimes back when we had these presidential candidates, especially during the Uhuru Kenyatta and Raila Amolo Odinga, even Raila Amolo Odinga versus Moi Kibaki, we used to have statisticians coming out and giving us like predictions. Who is going to win? Yeah, so they were telling us that we are 95% confident that Raila Amolo Odinga will win with this number of votes. So his votes will be between 5 million and maybe 6 million, something like that. You see, as a statistician, you can't tell me that Raila Amolo Odinga will get 10 million with precision. If you tell me that, I'll tell you that, hey, you are not a statistician, but you are what here? Like a witch doctor, sorcerer. Because now, I mean, how do you tell me that the share price of Safaricom will be 30 and then it turns out to be 30? Not possible. For us, we use the confidence intervaling concept. So we tell somebody that we are 95% confident that the share price of Safaricom on this day will fall between this and this. And even that range, you're not guaranteeing. That is why we are giving them a 95% confidence interval, leaving out what we call the margin of error. Leaving out the margin of error of 5%. So that if they come and tell us, how comes Raila Amolo Odinga never won? As a statistician, I can't start telling them that, you know what, there were votes that were stolen. That's none of my business. So I'll simply tell you, hey, whatever I promised you was at 95%. So there was a margin of me making an error of 5%, and I agree, I made an error. Yeah, I made an error. Yeah. So ladies and gentlemen, given this, you know, I don't even want you to go and get like 100% in an exam, but I want you to be at a position of being able to tackle each question that is given. For the 5 questions that you select, you should be a bit comfortable to get like 60% from each question. So up to here, Lucy, are we together? Have you been able to grasp something that you can now use to at least get some marks in your exam? Great. Thanks, Faria. Great. So then if you allow me, I'll be able to do Roman 2 of this question. I'll be able to go and do Roman 2 of this question. So Roman 2 of this question, what do we have there? Roman 2 of this question, what do we have there? Roman 2 of this question, they want me to test the hypothesis that the amount paid in monthly rent is 20,000. I love this because I've got one simple mean. Test the hypothesis that the amount paid in monthly rent is 20,000 at a 5% significance level. I love this, ladies and gentlemen. I really love this. Why? Because I'm going to put down my two hypotheses. So H0, H1. So in this question, I would want someone to give me what is U? What is U in this question? What does the population mean? It can't be that 22,150. That 22,150 is from a sample of what year? 200. So the mean here will be 20,000. It will be 20,000. So U is 20,000. Then tell me, from your understanding of this hypothesis, when we come to the null hypothesis, we could either have U is greater than 20,000, B, U is less than 20,000, C, U is not equal to 20,000. Which one in this case here do you want us to pick? Do you want us to work with A, B, or C? A, B, or C? C, thank you so much. Because they have not told us to test the fact that, for example, salaries will be more than 20,000. If they told us to test whether the salaries will be more than, then I would have done this, which would have been one tail, greater tail, bigger tail. So here they are telling us to test the hypothesis the amount paid in monthly rent is exactly 20,000. So if I get 19, I will say the null, not good. If I get 21, either way. So in this case here, you're right. Then our U should not be equal to 20,000. Our U should not be equal to 20,000. Thank you very much. Now from there, we go to the second step. The second step is the Z tables. Remember here, N is 200. So I'm talking about Z. So come and give us the Z tables value. So the Z tables value, remember still, when you use this not equal, this automatically means two tails. Two tails. And the level of significance, they have given me 0.05. Fortunately, we know that the level of significance per tail will be 0.05 divided by 2. And anyway, this already have been able to get 1.96, negative 1. Do you remember this 1.96 we got using the 0.05? Wait, they have forgotten this. They have forgotten this. Yeah, great. Great. So this already is taken care of. What I just need to show my examiner is that this area of emptiness, I will work with H0. This one I work with H1. This one I work with H1, the levels of significance. So from there we go to the Z calculated. Z calculated. So Z calculated, ladies and gentlemen, what do I have here? It is Z bar, or rather X bar, minus mu all over the standard error. The standard error, which of course is like this, all over root of n. So what is my X bar? Is there somebody who is able to read for me the X bar in this question? What is my X bar in this question? What is my X bar in this question? What is my X bar in this question? Anybody who is able to see the X bar, X bar, X bar, the sample mean, the sample of 200, the mean, the sample given there, what mean does it have? Thank you so much, Faria. It is 22,150. So it is 22,150 minus this mean. The mean here is 20,000. 20,000. And then I divide this by the standard error, which fortunately you great ninjas had already obtained when you are doing confidence intervaling. Already you have this standard error. You have done this. You have done this. You gave me a figure here, if I remember very well. And if you have forgotten, you can calculate it. We know the standard deviation given over root n. If you wish, you can, but I don't want to, because I know you already have it. Could you kindly give it to me? Could you kindly give it to me? Could you kindly give it to me? Could you kindly be kind enough and give it to me? Be kind enough and give it to me. be kind enough and give it to me. This standard error, somebody please give it to me. Thank you so much, Carl. It is 629,925. 639, I think. 629, yeah. Thank you, Hillary. Hillary Osukenya, 0.325. Thank you so much. So then here you have to be a bit patient. Use body mass. First of all, evaluate what we have in the numerator. So you say 22,150 minus 20,000 equals. Once you say equals, whatever you get there, you divide by 629.325. Give me an answer. Give me an answer, my good students. Give me an answer, my good students. What do we have here as Z calculated? Z calculated. What do we have here as Z calculated? What do we have here as Z calculated? What do we have here as Z calculated? So somebody's giving me a figure of 3.416. 3.416. So 3.416, where does it fall? Shaded, unshaded. Shaded or unshaded? Where does it fall? It's bigger than 1.96. It's bigger. So in the shaded, you simply say shaded, shaded. And once you say shaded, what do you do with the H0? What conclusion do we make? What conclusion do we make? What conclusion do we make? Reject the null hypothesis. You write in capital letters. You start by cheating this examiner. You really understand these things very well. So you write, therefore, reject the null hypothesis. Reject the null. Reject the null hypothesis. Reject the null hypothesis. And then you'll be able to get all the marks. Or reject H0, isn't it? Yeah, you can also mention at that significance level, yeah, because you're not rejecting it at all levels. But ladies and gentlemen, at this particular level, this is the foundation level. We don't want you to be very, very precise. If you just write reject null hypothesis, that is good enough. That is good enough. That is good enough. And that marks the end of this session, ladies and gentlemen. I happen to be having another class at 2 p.m. Yeah, for those of you who are still pretty new to RCM, do not hesitate. Do not hesitate to do what you do. Reach out to our customer care and we shall be able to, yeah, thank you so much, content. Yeah. So 0793 555 000. Yeah, it's important. And of course, continue marketing, Mwalimu. Continue marketing, Mwalimu. I always work with numbers. What I will do today at 7 p.m., I'll be able to welcome you to one of my advanced level classes. You'll see I normally make appearance, to any of my classes. I can't get less than 300. I can't get less than 300, sometimes 500, like BDA, even 700. But this lower level, they have not really yet appreciated this Mwalimu. The moment you appreciate me, then automatically I'll be able to create lots of time. If indeed you are not very, very ready for your exams. But if you are very, very ready for your exams, then we shall be able to stick with the 2 sessions that you saw in the low-hanging fruits here. So not unless now you go back to the WhatsApp group, convince people that we need to create time for these sessions. If you convince them like that, then we shall be able to discuss about more classes at 5 p.m. For now, from me to you, it's bye-bye. And don't forget our public speaking classes. Public speaking, whether you're preparing for your exams, public speaking, ladies and gentlemen, is really a key attribute, a key skill for any accountant. Because at the end of the day, you as an accountant, you'll be doing what we call financial reporting. You'll be doing what we call auditing. So at the end of the day, you'll be giving an opinion before an audience. So at RCM, what we have always done, we have these public speaking classes that are online. Like today, we have one session coming in at 4 p.m. So you attend that session. We normally mix public speaking with karaoke, the singing element, to bring in so many people, because you can also learn English through singing, especially in this case here, the issue to do with tonal variation. You see, like when you listen to me speaking, you go to see there are times I speak loudly and there are times I whisper. It's a public speaking skill. And the moment you discover that public speaking skill, you can never, ever go wrong. And if you can start it today when you have just joined your foundational level, then automatically you shall be able to really do very well in the near future. So is there somebody who will be able to create some time at 4 p.m. and attend our public speaking classes? You see how we handle them? Anybody will be able to? Yeah. Do we? Yes. Yes, you pay, but I'll be able to tell you how much. But today, no payment. Today is free. Today is free. Otherwise, thank you very much. Be blessed. Thank you very much. Be blessed. I'll send the link in your group. Yeah. If you have a class, you attend your class. If you have a class, you attend your class. Thank you.